SwayamPrabha. Digital India. Educated India.
Last lecture we were more focused towards material selection, and this lecture we are going to talk about manufacturing process selection. If you choose a material, then naturally the process has to be chosen next step, and many a times it will be process dictating the material or material dictating the process. So, it is a trade off, we have to keep both the weightages. If you give, both has to be given uniform weightages. While you choose, you also choose the process, or you choose the process and then choose the material, because finally what you want to do is you want to give an economical product to the customer, economical product which is performing such that by using that product the customer is happy. So, in this criteria I said cost is one of the major thing. So, the costing is predominantly decided by the material you use and the process which follows after the choice of the material. So, here we will see an introduction, followed by it we will see how to select a manufacturing process, a small algorithm, and then next we will see a primary manufacturing process. What are primary manufacturing process, what are secondary manufacturing process, what are ternary manufacturing process, and some design guidelines which will be slightly taking up from yesterday's lecture or the previous lecture. So, we will try to add some more design guidelines for while choosing a material or a process. Manufacturing process is a science and technology by which the material is converted into a final shape with the necessary structure and properties for its intended use. So, this is called manufacturing process. In manufacturing process, if you see, there are only three major parameters. They are nothing but pressure, time and temperature. You take any manufacturing process, you will have basically three process parameters. If I want to convert this pressure, I can write it as force per unit area. So, now in any manufacturing process, these are the three major parameters which dictate the efficiency of the process or the output product. So, it can be all the three be involved, or it can be only one involved, or a combination of two involved. So, we have so much of clarity, but why we are not able to dictate the manufacturing process such that we get very good products? The only thing is the weightages of individual parameters are still not known, or during the process the weightages keeps dynamically changing, which is very difficult for us to understand and model. So, that is why many a times the manufacturing process is called told to be as trial and find out or hit and go. So, that means to say you do some experiments, you get a good output. So, then freeze the parameters, saying that these are the best parameters for making this output. It need not be optimum. Over a period of time, many companies start working on their manufacturing process and move from the hit and go trial experiments, whatever they have frozen parameter, towards the optimum and fine tune the quality of the product. So, it is very clear in manufacturing we have three process parameters: the science and technology by which a material is converted into a final shape. This shape was basically, if you go back to design the principles, we talked about shape and form, that is what is a final shape, with the necessary structure and properties for which it is intended to use. The performance of the manufacturing process depends on, first is availability of material, which is directly proportional to the cost, then the capability required to process material, then the product dimensions and size, surface finish. Surface finish is very, very important, because if you are trying to mate two parts, the surface finish is going to be the contact surface. We would like to have as good surface finish as possible. Today we talk about nanometer surface finish. So, basically what is surface finish? If you try to take a surface of a shaft, and I try to take a zoomed place at this point, you will have undulations on the surface, something like this. So, here what happens when you mate it with a bolt, or when you mate it with another contacting surface, the contacting surface will sit on this peaks. So, if you see, these peaks over a period of time gets destroyed, and they try to fall in between the two mating surfaces. And if you see in the beginning, the load bearing area will be very less if you have a rough surface. So, that is why people talk about getting nano finish surface. So, nano finish means these peaks will be very less. So, this peaks would have now changed into peaks something like this. So, here, and when you do this, you will have, because when these peaks are predominant, when you try to machine these peaks, there will be next other peaks which come into existence. So, the load bearing area is now distributed. So, because of this, the wear and tear of the material is very less. So, nano finish is very, very important. So, people talk about surface, and the interesting part is people also talk about textured surface. For various applications, people also talk about it, and in surface finish, please do keep in mind that you can have two different signatures having the same roughness value. It is possible. Two different signatures, that means to say two different surfaces can have the same roughness value. So, you have to look at the figure and you have to correlate with the magnitude and then decide what is to be done. So, this is very important. The next one is tolerance. What is tolerance? Tolerance is nothing but when I try to make a part, it is very difficult to repeat and get the same accurate dimensions. So, because there is a variability in the input raw material, there is a variability in the human, and there is a variability in the machine. That means to say, as and when time goes, the machine parts have a wear and tear. So, because of this, what I try to officially do is, I try to say, okay, I allow you to have a small deviation. So, that deviation is the tolerance. So, that means to say, you will have a basic size maybe 20 millimeter plus or minus 0.1 millimeter, I say. So, here what I do is, I officially give you a small variation on the basic size, saying that you can't exactly make this. So, this is called as tolerance. So, this tolerance dictates the process, or looking at the tolerance, you have to choose processes. So, that is what is called as design tolerance, and then the waste produced by the process is also very important. Today, we talk about sustainable manufacturing. In sustainable manufacturing or in green manufacturing, whatever we use during the process, and the byproducts whatever it gets developed, and the waste whatever it gets developed, it is nowadays becoming a big challenge for environment friendly discarding. So, that is what we have just put. Waste produced by the process has to be as low as possible. So, the next one is the maintenance cost of the process. See, for example, when you talk about nanometer surface finish or when you talk about IC chips, it demands a room or an ambience where the machine is to be maintained in a proper manner. So, there is lot of maintenance cost which is involved. So, all these manufacturing process depend on all these parameters: availability, cost, capability, then product dimensions, surface finish, design tolerance, waste produced by the product, and maintenance cost. All these things we have to be considered while deciding a process. If I have to logically select a process, I follow these steps. So, the first step is selection criteria have to be written. Manufacturing volume. In manufacturing, there is nothing called a unique solution. Suppose if I want to produce a shaft of 10 numbers, then I use machining process. If I have to produce something like 100 or thousands, I always go for a rolling process. So, you see, depending upon the number, depending upon the cost which you can pay for the product, the process differs. So, manufacturing volume is one of the major criteria which helps in deciding a process. Same shaft, same material, only the number changes, the process changes. If I have to machine, I buy a lathe and then I start doing turning, which is not an expensive process. When I start going for a rolling, it is a capital intensive machine. So, it is little expensive. So, here the output has to be produced in bulk. Same way, let us take plastics. If I have to produce 5 spoons, so I will not do injection molding process. In injection molding process, you will have to produce at least 100 or 1000 in volumes, such that you take out the cost of the die which is used for injection molding. The machine is also very intensive. So, the other way around is, I will try to go for manual injection and I will try to have a very small sprue around which I put a heater and then I press it vertically down and then I inject it into a die and try to make one piece at a time. So, here the product might not be of a high quality and the time taken is large, but you have to understand that just by the volume the process changes. It will be injection molding, but it will be manually injection molding. The value of the product and the part geometry is also very important. Suppose you try to say the part geometry. Part geometry means if it is very large. If it is very large, so then you can say, for example, you take a lathe machine. In a lathe machine, the workpiece has to be held in a chuck. So, you have various types of chuck. One is 3-jaw chuck, you have 4-jaw chuck, sometimes you use collet, sometimes you put between centers, put a dog plate and then start doing it. Depending upon the geometry of the shaft, you decide what will be the work holding device. Same way, depending upon the geometry, you decide how the machine should be. For example, if you look at tires which are used for heavy trucks, heavy duty machines, heavy duty vehicles like trucks and buses, the tire has to be done by elastomer as the starting material, and then they put it inside a die and then they allow it to cure. The rubber is allowed to cure, put reinforcing with various items inside. So, the die is extremely large, which might run for a meter size. So, if you want to hold the die and then machine it, you can't do it on a lathe machine which is having horizontal axis. So, what we do is, we try to mount the die which is of around about a meter, again circular or cylindrical. So, we try to mount it on a chuck which is having in the and the tool is in the vertical axis. So, you see, depending upon the part geometry, the machine axis itself changes. It can be horizontal axis or it can be vertical axis, just by the geometry. I gave only one example. Okay. So, the part geometry also tries to dictate what should be the process. So, why is this important? Because the vertical, it is otherwise called as vertical turning machines, or some people call it as also vertical boring machines, and other names are given, but vertical turning machines are rare, you never find it, and this machine occupies lot of space. The investment is too heavy. The manufacturing process itself is different, though it is done by turning, but it is completely different. So, part geometry dictates, and same way, if you have a prismatic job and you have to do some machining operation on a lathe machine, or you have to make holes. So, then what people do is, they try to use a 4-jaw chuck. Mounting on a 4-jaw chuck is not an easy job, it needs skill. Okay. So, part geometry dictates the manufacturing process. The value of the product is also very important. The value of the product is the performance. For example, if you want a single piece, okay, single piece to be done, or a single shaft to be done. So, then what happens? You try to do it by casting, and when you want to do 10, you try to do it by machining, and when you want to do it by 1000, you do it by metal forming operations. So, if you see the property or the mechanical property or the behavior when you try to put these shafts on real time application, the casting fails first because of the grain orientation. Next machining happens, and the third one, last to fail, is going to be the sheet metal or the metal forming operations. So, the performance, that is what is called the value of the product. Value of the product also dictates the manufacturing process. Next is the required tolerance. The tolerance, if it is very tight or if it is very small, then it demands for more and more and more processes. For example, you turn, afterwards you try to grind, and then you try to lap, whatever it is. So that you, why? Because the tolerance is given. For example, if you say 20 plus or minus 0.1, then I will do turning. If I do 20 plus or minus 0.01, I do turning plus grinding. If I say 20 plus or minus 0.001, I will do turning, then I will do grinding, and then I will also do one another surface finishing process to get the output. So, look at it, it is all diameter of a shaft. So, you see, only by varying the tolerance, I add processes to whatever it is, right. So, this is what, and last one is the material. See, if I take polymer as a material, if I take rubber as a material, I will try to avoid machining. I will try to do it by other process, whereas like injection molding, or I will try to do curing, and I will try to get the output. So, depending upon the material, you try to choose different processes. For example, if I have a ceramic material, ceramic pipe to be made, it is very hard to do machining. Why? Because in ceramic it is a brittle failure, and moment there is a brittle failure, the surface finish whatever you get is not going to be under the control of the process. You have to do some other applications, or you have to apply some other forces to make sure that the machining happens, gives you a very good surface finish. Or people do not even try to do machining, they try to take the starting material will be a powder, they put it inside a die, compact it. This compaction can be in cold isostatic pressing or hot isostatic pressing. You get the finished product directly rather than undergoing any of the machining cycle. So, here depending upon the application, if it is going to be high temperature, then you choose a ceramic. Then when you choose a ceramic, you do not use subtractive process, or you do not use the deformation process, or casting is not thought about. So, this is what I am just trying to put it here. So, based on these 4 points, you keep it as a selection criteria and decide the process. After identifying the process by step 1, a smaller range of process will be available. So, here to a large extent you have narrowed it down to what is that. Then in the next will be with small variations. So, where in which we try to put the fixture, we try to talk about the tool, all these things will come here. At this point, you should ideally work with an experienced manufacturer to identify those processes that can satisfy the requirement of quantity, material requirement, and part geometry. So, it is after deciding the first step, manufacturing process, it is now going to be more towards the process parameters, work holding device, tool geometry, something like that. Then what you do is you try to evaluate. So, now you have chosen it. Once you have chosen a process, the next step which comes into existence is to how do I evaluate the process. You already have a result now. So, you have to now check the result whether whatever I have got is correct or not. And in manufacturing, I repeat, there is nothing called unique. So, you will have multiple solutions for the same problem. Now, you have to evaluate each solution and try to identify whether it is good or not. So, next comes the evaluation of the process. So, evaluation of the process, herein we are trying to talk also about reducing the scrap. So, that is what is the prime focus. So, after identifying the potential process from manufacturing a product, it is time to evaluate them based on less broad parameters such as process capability. So, we can talk about 6 sigma, okay, whether whatever I produce, I get it within the tolerance, and I can produce it for a longer time. What is the processing time? See, in product design, when I started itself, I told you there are customers, they need a product, and you have to have it in mind how quickly you reach out to those customers with those products. If your time is very large, let it be for prototype making or let it be for final product making, if the processing time is large, then you will not be there in the race. Okay. Processing time is one parameter which we try to evaluate the process. Next, the tooling and the equipment cost. If it is very expensive and if the volume is very less, so naturally what happens, the investment you made by number of parts you produce, you just divide and the unit price will be exorbitant. So, now what will happen, if you, because your investment what you did on the manufacturing process is very large, so we do it. For example, in IC chip manufacturing, the investment on the process is extremely large, extremely high, but the volume what they produce is very high. So, when you divide it by the investment by the number of parts produced, the cost goes down. So, in electronics industry, by and large they follow batch production. So, in silicon, one wafer can produce almost close to some 100 ICs. So, here you should look at the tooling and the equipment cost. If it is very large, naturally the volume should be large. If it is very small, you can always try to have a trade off, okay, I can have a very small volume. Then the degree of automation is very important. Why is degree of automation which is very important? Today we are in the era of Internet of Things. So, when you have Internet of Things, understanding there is a customer, he wants 20 parts to be produced. Quickly what we do is we try to automate, place a bill, place an order to him, get the material, add it to the to your inventory, and immediately from the inventory you have a conveyor which moves to the machine and you start producing. So, that is the level of automation we are talking about. So, if you look at all the process industries, the level of automation is very high. Process industries, the level of automation is very high. It is very high. So, next one is the skill required for operation. Today what is happening is we are trying to, once you move towards automation, we are trying to remove all the unskilled labors and use only, at certain places we try to use a skilled operator to do it. For example, for quality check, for assembly. Today industries have gone to a level, all the parts, for example, you have a product, it has subassembly, from this subassembly it has parts. Almost all the parts are nowadays, it has been given for subcontract. And from here, now what has happened is they have also given from here to here, sub-assemblies are also now given subcontract. So, what industries have started doing is, they are started doing only assembly, the product. So, here what is happening, you have to evaluate the performance of the subassembly and then you have to assemble inside a product and get the required output. So, here we are looking for the skilled operator. So, you should also look at what is the skill you expect in your process. So, this is very important because you do not have a skilled operator everywhere, or skilled operator is very expensive. That is why in today what has happened is people have started working on computer assisted process planning or computer aided process planning, people have started using, so that the skill of the operator need not be a bottleneck in deciding the process. Next, the waste produced after the process is very important. You talked, when you do any of the machining operation, we use coolant, and once the coolant is used, so these coolants, there are two types of coolants, one is natural coolant, another one is synthetic coolant. Synthetic coolants are predominantly used, which are, it can be oil based or it can be chemical based. So, these coolants have to be discarded. So, discarding this is a big challenge. Same way when you work on process industries and chemistry, you have to discard some of the byproducts. So, that is very, very important. If the discarding cost is very high, then it is not going to be a viable process. The last one is the post processing required. I try to make a chair, and in that chair I would like to have a texture of my choice. If you say that after making the chair, try to use a single point cutting tool and either machine or use a skilled operator and try to remove it, it is going to be costly. Or if I say that after making a chair, try to paint the chair with green color, it is not possible. So, the post processing operations have to be as minimum as possible, or I will put it this way, today we look at near net shape manufacturing. So, to a large extent we try to get the required product to the final stage. Just do final small tweaking such that it can get into the market. So, these are the criterias which we always use in evaluating the process which is chosen for producing a part. Process capability to reduce the scrap produced and have a consistency in the process. Processing time, it has to be less. Tooling and equipment cost has to be as low as possible. Degree of automation has to be as high as possible. Skilled labor requirement for operation has to be as low as possible. That means to say, I have automated, then the waste produced by the process has to be as minimum as possible, and then it is the process industry. See, for the PCB, the biggest challenge is they use lead as one of the elements, let it be PC computers or let it be even mobile phones, smartphones. They use lot of rare earth materials. One, it is expensive. Two, discarding is a big problem. So, people are now working on how do I salvage the rare earth materials which is used in those computers and bring it back to use. So, for example, cadmium is used, platinum is used. So, people are working hard on it, and now what has happened, because you have used it, now it has got discarded. You can't discard it in free in nature. So, you try to process it, and when you process it, you try to make it once again a useful material and then start going. And in the same way, when you try to talk about chips which are getting produced, it is the same thing. What do I do with the chips? So, the selection, after doing this the three, first what did you do? You had a selection criteria you had, then you have identified a process, then you have evaluated the process, then the fourth step is selection. You should now be able to use the weighted decision matrix. Many a times in your selection, if you have 3 parameters, it is always the weightages you have to put, and weightages, and you have various criterias. So, each criteria you give some weightage and you multiply it with some factor, and that when you sum it up, it tries to give you in some numbers. So, these numbers help you in taking a decision. For example, people talk about SWOT analysis: strength, weakness, opportunity and threats. So, here also what people do is they try to say, put all the points in strength, put all the points in weightages, put all the points in opportunities, S, W, O and threats. And now what they say is, they try to say you give some weightages. Okay, this is weakness. So, weakness, suppose you feel the weakness whatever is there in a process or is there in an individual, this weakness is going to completely dictate the performance of his future, then you say weakness, this is 90% you give. So, when you multiply all those things, you will get a summation. So, with this you can see whether the strength is very high for this particular process, weakness is very high, opportunities are high, threat is high. So, then what you do is you try to change those things and convert or choose another process wherein which the weaknesses are not high, strengths are high, so that you can start taking it. So, always in taking decisions we have the weightages factor, let it be QFD, we have this weightage factor. You should now be able to use weighted decision matrix you created in step 3 to identify the best process. If you clearly evaluate each element, giving extra weightage to those elements that are most important, the results will be single process that will produce the part required to the standard requirements for an acceptable cost of production. So, these criterias you try to give weightages, and after doing this weightages you sum it up, get it, and then you choose a process. So, now let us see some of the processes. So, when you try to talk about manufacturing, so first classification of processes are primary processes. Primary processes are, you try to take it from a ore, or you try to take it from, first is ore and then you try to take it from metal which is there in bulk. What you do is you try to melt it and then you try to give a shape to it. So, if you talk about manufacturing, I can very crudely classify into constant volume process, subtractive process, additive process. Okay. In constant volume, I can apply heat which is nothing but casting. I can apply force, which is nothing but metal forming, and so here you can also do, this is heat is to melt. Okay. Then heat I can do to do a treatment, heat treatment. Here the volume, the shape is not even changed, the size is not changed, only the microstructure is changed. When you talk about subtractive process, you have two, wherein which you use a tool in coming in contact, or you do non-contact machining, and then you try to remove material from the starting material to produce a required output. Additive manufacturing, which is very much talked about today, it is nothing but you use building blocks and you try to add material at those places where you want to construct a material, and then you keep moving. So, this is how we predominantly classify, and if you want to do in manufacturing much more classification is trying to produce a part and trying to assemble parts. So, assembly is the other classification. So, when you try to look at the processes, constant volume, heat. So, here what we talk about is you have starting material, you try to heat it above the melting point of the material, so that you try to induce viscosity. So, that means to say you take it to a lower viscosity, and then you allow it to pour inside a confined mold or a die to get the required part. So, that is here casting. Okay. And then by force is nothing but you try to give a force through a machine tool and then try to deform a bulk material or a sheet material and get the required output. So, those things are called as metal forming, and here force is predominantly used. Heat treatment is try to play with only the temperature and time, you try to play with the grain structure, which in turn influences its performance in terms of mechanical property as well as in wear and tear. So, that is what you do. So, here we are more focused towards investment casting. Investment casting is very much used for those products where the features which has sharp in features which has to be produced. So, we always go for investment casting. Here I have just taken only a glimpse of certain process and I have put here, but there are a spectrum of process available. So, investment casting, so a metal mold is made for a part, a wax is injected into the metal mold. So, this metal mold can be made through additive manufacturing also today. So, a metal mold is made, a wax is injected through the metal mold as shown in the figure. So, these are all the molds. The resulting wax part are then gated. So, gate is nothing but you have a part, you have to connect it to the main reservoir. So, this is the gate. So, gate to the sprue, the reservoir is nothing but the sprue, okay, to form a cluster of wax molds which can be used to increase the production rate. So, that means to say I can have gates, these are the parts, wax parts. So, what happens when I try to pour a hot metal, this wax melts off and then it, so the metal whatever gets filled up is the final end product. So, here you can make it up to from the weights can be from 0.001 gram to 35 kilos, you can start making it up, and then you can have a minimum wall thickness of this to this, the tolerances which are given is this. Okay, you can also do it by sand casting, you can do by die casting, you can do it by pressure die casting. So, all these things are some of the advancement, and all these things are comes under classifications of casting. So, that I request the students to read some introduction to manufacturing process book to get more knowledge. Next one is a metal forming process. So, this process is nothing but an extrusion. So, extrusion what we do is we try to keep the raw material, okay, raw material inside a die, and then here you see there is a punch which is pushing, and this punch is activated by the hydraulic system whatever is there, and this tries to give you the pressure. So, this pressure tries to get applied on top of the aluminum, and then what we do is we have a small exit, an orifice through which the material is squeezed out. So, this squeezing out is called as extrusion. So, whatever you have on the die shape, you get the profile on the extrusion which comes out. So, here we can do it for aluminum, people have started using for steel, and many more applications you can start doing it, right. So, here a metal billet are forced by a mechanical or by an hydraulic extrusion. This is the hydraulics, and here is the hydraulic oil giving pressure. This is the piston which moves down, and this piston moves the punch, and this punch tries to do it. So, here you apply force and then you try to extrude material, and then for example, all the steel rods of diameter a little smaller, they are extruded. And slightly large diameters are rolled. So, you can also do rolling. So, what happens is, rolling, when you do, you have to reduce the diameter in several steps, you get it done. And in here also, so you should keep one thing in mind is, if you want to reduce the diameter drastically, it is not advisable. So, it is better to do it stepwise, but here what we do is, we try to play with the geometry and try to get what best we want. But these are some of the tricks which you have to first understand the process and then try to produce. Wherever you want to use extrusion or metal forming operations, you should have a volume large. In casting, you do not have to have, you can have from number 1 to maybe even 10 numbers of production you can have, a batch size parts can be 10 or even 100 can be produced. But when you talk about metal forming, it has to be large. We all generally talk in terms of thousands, hundreds to thousands. Again, these numbers are not sanctity, depending upon the cost, depending upon the material, you keep changing with the processes.